Hey guys, welcome back. So today we're gonna do just a couple more things with conversion factors. So we're gonna start on page 94, and I'm gonna add a few things to this map that we made last time. Now, if you don't have room to add everything that I'm adding, feel free to go over to page 95 over here and like redraw the map. That's totally fine. Even though this is section 9.6, we're actually going to use this for some more 9.5 stuff. So if you need to do that, you can. If it fits on the page where it is already, you can draw it on this page. We're just going to draw a couple more units on here. So last time we practiced going from grams of one part of an equation to grams of another part of an equation, and we got there by going through moles of those different parts of the equations. It turns out there are some other units that we can go between here, and they are molecules and atoms. So I'm going to draw another little road and another oval for your unit. This one's big because I'm going to write down molecules. This can be either molecules or atoms of A. Now that's not molecules divided by atoms. This is just saying it can be molecules or atoms of A. I should probably just write or instead of a slash there. And then here, I'm just going to make this one be molecules or atoms of B. Okay, now we have converted between moles and molecules before, and you might remember what we used to convert between those. It is the Avogadro's number conversion factor. So we use 6.02 times 10 to the 23rd. I'm just going to use molecules for this example. Molecules of B per 1 mole of B. That's the number of molecules in 1 mole. Okay, and the conversion factor would be the same on this side. 6.02 times 10 to the 23rd molecules of A per 1 mole of A. Now, when you're writing out these problems, it's really important to write out molecules. Otherwise, it's really easy to get it confused with moles. And moles and molecules are not the same thing. A mole is a big number of molecules, but it's not the same as molecules. So we're just going to do one example where we're kind of going between molecules and grams. So we're going to go over to page 95 for this example. And the equation we're going to use is a different one. It's going to be 4Fe, so iron sulfide, reacts with 7O2 to produce 2Fe2O3 plus 4SO2. Okay, and then our question is going to be how many grams of O2 are needed to react with 2.4 times 10 to the 24th, that's a 4 right there, molecules of FeS. Okay, so we are starting with FeS, so this is going to be molecule A, like our starting molecule, and we are trying to get to O2. So that's going to be B. And if we look at our little map, we are starting at molecules of A, and we are trying to find grams of B. So we basically need to go from molecules of A to moles of A, and then to moles of B, and then to grams of B. Okay, so let's set this all up. we're going to need a lot of space because we're going to have to write some big scientific notation numbers. So we're going to start out with our given, 2.4 times 10 to the 24th molecules of FeS. And then, to cancel out molecules, we need to use our 6.02 times 10 to the 23rd conversion factor. That's always going to be the same number. Anytime you're trying to cross out molecules, you need to use 6.02 times 10 to the 23rd molecules of FeS. That is the number of molecules in 1 mole of FeS. So my molecules are gone. Now, I need to get from moles of FeS to moles of O2. So you hopefully remember that to do this, we use the coefficients. So the coefficient of FeS is 4, so we're going to have 4 moles of FeS down here, and 7 moles of O2 up here. So my moles of FeS are gone. And now I just need to get to grams of O2. So to do that, I need to find the molar mass of O2, which is really easy. The molar mass of oxygen is 16, and there's 2 of them. So that's going to be 32 grams of O2 in 1 mole of O2. So 32 grams of O2 is going to go up here. 1 mole of O2 is going to go down here. Okay, now I'm going to spend some time showing you how to put this stuff into your calculator, because that is honestly the hardest part of this type of assignment. Is just making sure you get the scientific notation right. So I'll show you what it's like on an iPhone, and then I have a calculator that's kind of like an Android calculator, so I'll show you that as well. So let me turn on my screen rotation. On your calculator, if you have an iPhone, you're going to want to turn it so that you can see all these extra buttons. And what I would do always with these problems is multiply everything on the top, write that on the top of your fraction, then multiply everything on the bottom, write that on the bottom, and then divide. Okay, so we need to do 2.4 times 10 to the 24th. Remember, there's a button on your calculator that means times 10 to the, and it's these little capital E's, not the lowercase e, that's something else. So we're going to do 2.4 e 24, that means times 10 to the, okay, that equals that number, and then we're going to multiply by 7, then we're going to multiply by 32. I'm going to write that number up here. It's 5.376 times 10 to the 26, and that's grams of O2 up there. And then on the bottom, we're going to do 6.02 E 23. Now don't do times E. You really just push E. That's it. And then multiply by 4, and you're going to get 2.408 times 10 to the 24th. Now, before we divide this, let me show you what it would look like if you were using Android. So, my calculator that's kind of like Android is this one. On Android, there's not, so see, this one has an E button, but on Android, you don't really have an E button exactly. So what you need to do is put your scientific notation in parentheses. So you need to do 2.4 times 10, and then you need to find a button that's like x to the y or x to the n. So there's mine, and then you need to type 24, and then you usually need to get over so you can make your parentheses be a normal big size parentheses, and then do times 7 times 32, and you get that same number that we got. And then you do the same thing down here. Okay, now I'm going to go back to the iPhone calculator. Okay, and I'll show you how I would divide these. So I would just type 5.376 E 26, and then hit divide by 2.408 E 24. And I got like a pretty normal number. I got 223.26. Now, a lot of times when people are doing this wrong on their calculator, they end up with a number that's like times 10 to the 40 something. So if you end up with something times 10 to the 40th, that means that you typed something in wrong on your calculator. So your calculator thought it was supposed to multiply these exponents instead of divide them. So if that happens to you, re-put it in on your calculator. Make sure you've got your parentheses. Now, if you're on Android, for you, this division is going to look like this. You're going to go parentheses. Oops, let me clear all that. Okay, parentheses. 5.376 times 10 to the 26th divided by, more parentheses, 6.02 times 10 to the 23rd, close your parentheses. Oh. And I want you to solve that. There we, ooh. Oh, that's not what I was supposed to divide by. Sorry guys, I just like automatically put that in there. I was supposed to divide by, sorry, I've never used this calculator before. I kind of don't know what I'm doing. Okay. 5.376 times 10 to the 26th divided by 2.408 times 10 to the 24th. There we go. And now I get the right answer. So that's how you solve problems that involve switching between grams and molecules and moles. And you can go, from molecules to grams. You could also start with grams and go to molecules. There will be some problems on your assignment where you're doing that. You can start with moles and go to molecules. You can start with molecules and go to moles. You can go anywhere as long as there are paths connecting the units. All right, so hopefully that makes sense. Again, I'm always willing to meet with you and talk more about this one-on-one. This is a tricky section and it's especially tricky to learn online, but hopefully it seems like you guys are doing pretty well. So good job, keep up the good work, and we'll see you later in the year maybe, or maybe not, we'll see.